Go.
Hi friends, welcome to this video on ratios and proportion. So today's class will look at ratios as part of the initiative Success Chambers CAT preparation quantitative aptitude. So till now we have covered percentages, but now we'll look at ratios as well, which is an important part of CAT preparation as well as of other exams like bank PO. So let's start. Ratios. So whenever you talk about ratios, two things would come to your mind. So how do you express a ratio? Ratio, you would express it as something like A, this is colon, and this is B. What it actually means is A upon B. So if I say two numbers X and Y are in this ratio, A is to B, what I would actually mean is, in a simplified form, they are actually A upon B. So if I say maybe numbers like 24 and 20, so they are in a ratio of, you simplify these, you cut this, you say 6, 5, so you say they are in a ratio of 6:5, that is written in this form. So this is how a very simple example of how ratios are done. But how do you express ratio in a number form? So you have converted from numbers to ratio. But how do you go the reverse way? So you have to always think, in the reverse way, because answers would be given you in a reverse way. So if you can think from answer to question, you would actually know how the process works in that question. So if I say a ratio is given A, suppose AB, A is to B, how do you actually write it as a number? So this may not be the number. So you would say AK and BK. These are the numbers. So K is the common multiplier here. So you would say the numbers are AK and BK, and the simplified form would be A is to B. Just like 24 and 20 are AK, BK, and A is to B is 6:5. But if I say two numbers are in the ratio 3:5, so if I have given something like pencils to two persons, Rohan and Mohan, in the ratio 2:3, so how would I actually say that? So let's take a number like 24. Just like, and if I say I have given these in the ratio maybe 2:4, I have divided these in the ratio 2:4. So if I want to find out how much actually I have given to one person, I would say 24 into 2 by 6. Where does this 6 come from? 6 comes from this 2 plus 4. Why we do this? Because something that is 6 is divided in the ratio 2 and 4, which we have written in the numerator. So 2 in the numerator, 6 in the denominator, and this way you will find out that it's 8. So this is 8, 2, and the remaining is 60. So this is how you actually calculate ratios. Very simple example taken. In the next videos we would obviously take complex examples, and the level increases with each video. So next, moving on to the comparison of ratios. So if I say there are two ratios like 15 by 20 and maybe 24 by 30. Okay, how do you compare them? So one way of comparing is you can simplify them, and you can say 3, 4, and you can say 5, 4, so it is 3 by 4 and 4 by 5. Very simple. But if suppose the numbers are very tough, so maybe you can say 62 by suppose 15, and second number is maybe 34 by 45, right? So in this case 15, so let's take a different number. Let's take a number like 50, so that they are not the multiples. So in this case, if you want to compare these two numbers, you can either calculate the resultant fraction that is there, or you can find out a common multiple. So make this denominator common. So this gives you a point of comparing, and then you will actually compare only the numerators, because the denominator is common and the numerator, the size of the numerator would actually tell you which number is bigger. So in this case you can say the LCM, just on a broad basis I can say I take a common multiple like 150. So if I convert this into 150, I would write 34 into 3, 50 into 3, right? And if I have to convert this, I would say 62 into 10 upon 15 into 10. So now you will see that they are the same denominator, and you will calculate, it turns out to be 620, the numerator here, and here the numerator is less than 100, you can clearly see that. So this is a simple example, but in case of complex situations you would actually require this technique. One another important technique that I would like to demonstrate here is of percentages. This is what I figured out by practice, and very important, very helpful to make fast decisions and do these type of questions very quickly. So if I say something like 20 by 25, and if I say something like a number like 30 by 35, look very similar and very tough as well, unless you go to simplify. So you would say if I increase this by 10, suppose I increase this by 10, so actually 35 is 25 plus 10, and 30 would be 20 plus 10. So I am increasing this denominator by a certain amount so that it actually becomes equal to this. Suppose some percentage, x percentage. So if I increase this by x percentage, it becomes 35. And similarly, I would increase this by x percentage to compare. Because x percentage increase above both, it gets cancelled, and it is actually the same number. But you would see x percentage of this number that would give this 10 would be actually a higher percentage of this that would require to give 10. So and it becomes 30. So actually it would be less than 30. So just to calculate, I would say maybe 10 is about, you can say, 40% of 25. So if I say I have to increase this by 40%, so I would decrease both numerator and denominator by 40% increase. So if 40% increase is done, the denominator becomes 35. But what would the numerator become? Numerator would become 28. So you say this is the method of making one smaller fraction into the exact the next fraction by making the denominator same by increasing in terms of percentage. Very simple. And once you get hang of this, you can actually do calculations very fast, because you can see 40% of 20 would be around 8, and it is certainly less than 30. So this is one thing that can really help you do calculations fast. So in the next video we'll continue this. This is all from Ratios 1. Thank you for watching, and stay tuned to Success Chamber.